Hello, everybody, and welcome to this week's episode of the Visual Studio Office Hours. I'm your host for the next hour or so. My name is Mads Christensen, and I'm very excited because today we have a subject that, to me, as an extension writer, is something that I'm very, very interested in, and it's the editor of Visual Studio and its complex nature, because it is kind of, it seems at least to be rather complex. And you might not think about that when you're typing in some C# or C++ or JavaScript into Visual Studio, into the editor. You might not think about what complexities lies behind it, but my understanding is that it is very complex. And to help shed some light on that, we have none other than from the editor team itself, Christian Gunderman. Hello, Christian. How are you doing?
Great. Thank you for having me today, Mads.
Yeah, my pleasure. I'm very excited to learn more about how the editor works, and I think a lot of people will maybe appreciate Visual Studio even more when they know just how complicated something like an editor actually is to write. So, but before we get into all that, Christian, can you just give a little presentation of yourself? Who are you? What do you do?
Sure. All right. My name is Christian Gunderman. I've been on the editor team for about 4 years now. My team owns, I would say, probably the majority of the surface area that you interact with in Visual Studio on a day-to-day basis. So that includes the error list, editor, a lot of the code search windows, find, etc. And most importantly, we own a lot of the extensibility surface of the API as well.
Right.
Extensibility surface of the IDE as well.
Yeah, because the editor itself is like a very large component, and so there's a lot of extensibility points to it. We can really extend a lot of different aspects. And I guess the different language implementations that ship in Visual Studio already does that. You provide the basic API, and then let's say the C# language service or the Roslyn language service, they come in and they use that API to colorize keywords and identifiers and differently, and provide IntelliSense and light bulbs and all this sort of stuff. And this is all part of the editor, right? And so what are the actual components of the editor?
So in a lot of ways, the editor is kind of, it's a bunch of Lego blocks that you can put together for a bunch of diverse scenarios. So of course, the traditional one that everyone's going to be familiar with is the code editor, where you spend the majority of your time. But we also use the editor in additional panes that might be counterintuitive or non-obvious. We use it in the output window. We use it in CodeLens itself. If you've ever used peek to definition in the editor, that is actually a nested editor. Apologies. I'm so sorry for the interruption. And we also use bits of the editor as well within each of the individual language services. So the Roslyn out-of-proc components that run and communicate with the IDE, parts of the up-and-coming code spaces, also LiveShare, etc., use bits of the editor as the fundamental building blocks for all of their scenarios.
Okay, and so all these Lego pieces, can you just talk about like what are they? So I mentioned a couple, right? But I feel like there's a lot more. You mentioned CodeLens, you mentioned a few other things, but what are the different pieces? And maybe more importantly, what is not the editor? Like, where does the editor start and where does it end? Like, where's the rest of the API, the rest of the Chrome or the shell of Visual Studio? Where does that start?
So ultimately, I would say the most fundamental part of the editor is the text buffer. So the text buffer and the text data model in general are much more complex than they really look at from the surface. But essentially, we have this text buffer data structure, which can take one or two forms. The base text buffer is just a way of storing text and making it efficient to make insertions, deletions at any point in the text buffer. But then we have a series of stacks on top of that, the projection stack and the elision stack, which are responsible for implementing support for things like mixed languages, allowing the C# and the ASP.NET Razor languages, for example, to coexist in the same document with completely independent language services. And then also implementing a lot of the niceties that you've come to get used to, such as outlining regions on top of the editor, CodeLens, code colorization, structure guides, etc. So really, I think the most fundamental unit of a text editor is that text buffer, that data structure, and how an extender can interact with it.
Right. So when I type, text is inserted into the text buffer, and when you delete it gets removed and all that sort of stuff. So everything in there, including IntelliSense and the regions, things that has to do with me typing, for instance, is the editor. But then it goes beyond that too, right? Because something as simple as showing the line numbers in the margin and the zoom control at the bottom, scroll bars and margins, and that's part of the editor API surface as well, right?
Correct. Yeah. So let's just walk through a sample scenario. I like the example of typing because I think that's something that seems fairly simple, but there's a complex sequence of events that happen to relay out the editor every type char. So if I, as a user, I type something, I type in H or something, as in hello world. First thing that happens is that a window message is raised by Windows. That's going to bubble up through the command chain, and it's going to be intercepted by the editor. The editor is then going to redirect that to the active text document. And then it's going to create an insertion in the text buffer. And depending on which particular language you're using, depending on what view of the document you have, if you have outlining enabled, if you're in a mixed language scenario, et cetera, that's going to get routed down to a specific constituent buffer, which is part of a graph of buffers in this projection graph that we were talking about before. Then, sorry.
No, go ahead.
Then once that text change has been committed to the underlying buffer, the text view is actually subscribed to an event on the buffer or on the buffer group. And it will, in response to that, relay out the text view, going through and repainting the lines that need to be repainted, and then going through in sort of a sequential fashion, raising events for each of the extensions that have plugged in and say that they need to be alerted as to this change.
Okay, so you mentioned text buffer, and now you're mentioning text view.
Mm-hmm.
So what's the difference, and how do they relate?
Yeah, so the text buffer is the underlying data structure that stores the text content itself. And there's actually a couple of specialized forms of text buffers, which you can layer on top of there. I talked about elision before. That is the specialized text buffer, which powers the outlining region experience. There's the projection buffers, which power outlining regions, but they also, this might be new knowledge for those of you on the call, but it also powers the tooltips that you see for structure guides. Any place that you see bits of text from various disjoint parts of the document brought together into a single view are powered by projection.
Okay, and so the view itself is hosting the text buffer, and when you have a line, like the concept of having lines, like line 38 or whatever,
yeah,
that is a concept of the text view, not the text buffer. The text buffer doesn't know about lines; it just knows about characters, and a character could be like a new line, like a line break, an environment new line, if you will. But to the text buffer, that's just a character like any other character. Is that how to think about it?
That's pretty close. So the text buffer does have its own concept of lines, but those are not lines from a visual standpoint. Those are lines delimited by line break characters. So if you have a /r character, /n character, those are logical line breaks. But then you have text view lines, which may map between those two one-to-one, or they may, if you have word wrap enabled, actually be some additional lines in there as well.
Yeah. Okay. So those different language implementation or language services, or even extensions, and I guess it's fair to say here that all extensions operate using the same API as all the built-in language services, right? So it's all the same thing. So whatever Roslyn and C++ and JavaScript can do with the editor, so can third-party extensions.
Correct.
And so we're talking. Oh, go ahead.
I was going to say one thing I wanted to interject with is, and in fact, lots of the editor presentation layer, a lot of what you see is actually built using those same APIs as well.
Yeah, and so there are different things you can do whether you're on the text buffer level. So that's what you were saying, the data model. So that has to do with like how to colorize the document, like what's a keyword and what's an identifier. Should they be blue or whatever color? And also provide IntelliSense tooltips that are contextual to what the mouse hovers over. That has to do with the data model. And then we have the text view, which is the visual representation of it. And that could be, well, what could that be?
So I think at the most fundamental layer, that's going to be the actual rendered text line. So there's a layer on top of the text buffer, which is responsible for keeping track of the lines that you have in view. And anytime you type a type char, we don't want to repaint the entire text view. We want to be able to use the majority of it over again. So it re-renders just the line that was changed and pulls the rest of them out of a cache and redraws them, repaints them, translates those pixels if needed up, down, left, right. And that's the most fundamental element of the text view. But there's much more than that. There's the margins on either side, which are used to actually implement the scroll bar. So you have a text view margin API, and the scroll bars are just a standard text view margin. So if you wanted, for example, you could create your own replacement scroll bar for Visual Studio Editor. And then all the other features as well. Code Lens, I heard you talk about code colorization. So code colorization is just a specialization of the built-in text view line rendering, where we take those existing lines and we superimpose some formatting information, which changes the colorization, font, the bolding, etc.
So every time you type a character, you can go through. There's some things that hook into or that listen to some of these events, right? So when there's a text buffer change, the text view renders whatever the change was, like you type a character or something like that. But also then figure out, should I invoke IntelliSense? Was it a dot? Should I show IntelliSense or should I commit from IntelliSense? Should I show a light bulb? I guess the light bulb is also part of the text view text buffer. I don't know.
Yeah, so light bulb is kind of an interesting example, because I think that's another example of kind of what we were talking about before, where a lot of the editor is actually built using editor API. So the light bulb fundamentally it's two or three things. It's a margin on the left-hand side, built using the margin API, but it's also a pop-up, which pops up next to your quick info tooltip. And so it's actually built using that same quick info tooltip API, and the mouse hover API is within the editor as well. So we use all the same API surface area that we exposed.
Can you explain what is quick info?
So quick info are those tooltips. So if you hover over some C# code or some C++ code and you get some documentation information, that is provided by the quick info API. And it's just a fancy term for tooltip, ultimately.
Okay, so it's like, is it a Visual Studio term or is it like an industry standard term? Quick info?
It's probably a Visual Studio branding term, to be quite honest.
Okay, and this is something that has existed for many, many versions of Visual Studio. This is not something we just came up with, right? It's an old concept.
Yeah.
Because why not just call it tooltip?
I couldn't tell you.
Right. But that's how it is, right? Because things evolve over time, and now even the tooltip can host the full like colorized C# string in it, right? Instead of being just let's say a dumb tooltip. You can even have links that you can click in the tooltips. That came out a few years ago, I noticed.
Yeah, we added that in for C#, I believe, somewhat recently.
Yeah, I think we used it on the web team as well for HTML. So if you hover over something, it shows you information from the W3C about what is a section tag or something like that. And then with a link that will take you to the definition. So that was super handy. Okay, so text buffer, text view. And then we have the whole notion of you can actually inject WPF directly into the editor itself, right? With something called adornments.
Yeah.
What do we use that for?
So I'm glad you brought up adornments, because we actually use them in a lot of different places. So a couple of somewhat obvious examples of an adornment are the outlining region. So if you fold a section of code, you'll see a little 3 dots adornment that pops up. And if you double click it, it re-expands the code. So that's one. Another is code lens. So over methods, you'll have like a references indicator. It will say this particular method is used in 4 or 5 different locations. That's another type of adornment as well. And then I think error squiggles are probably the most obvious one.
Oh, but they use a different API, right? They're called a tagger or something like that. Or is that underlying like the same concept behind the scenes?
I'm glad you mentioned taggers, actually. So tagger is just a way of providing abstract information about a span of text to the editor. And features build on top of taggers. So if you look across the sum total of all the different features that we have in the editor, the majority of them are actually offered through a tagger. And then we have an adornment layer that we've implemented for you, where if you provide the right kind of tags, we'll actually generate the adornments for you.
Okay. So it's safe to say that a lot of things here are going on, and there's a lot of different Lego blocks that come together to provide the full experience of the Visual Studio Editor. So when someone hits a key, it goes through a list of all these different things, and depending on the language, C# is different from C++, from JavaScript, and so on. Different event handlers will act. And so does that mean that perf is like potentially a big issue when you're typing?
Yeah. I'm glad you mentioned typing perf, because I think this is something that's very near and dear to our customers' heart, and also to our heart as both product owners as well as users of this product. I use Visual Studio every day to build Visual Studio, and if the perf is not great, then I suffer as well as my customers. So there's a number of design choices that have been made with the editor, both in the past as well as in the future, that we're using to try and drive this typing performance. One of the big things is a transition away from synchronous APIs. A lot of these synchronous event handlers and a lot of this happens, therefore something follows on the same thread, to async and off the UI thread APIs. One of the biggest changes for this actually is async completion, which was added, I believe, in the 15.x timeframe, so in the last year or two.
So 15 being Visual Studio 2017.
Yes, yeah, that's correct.
Yeah, the 15th version of Visual Studio. Yeah. Okay, so if you're moving to async, so you said async completion. So completion is IntelliSense. Internally we call that completion. But how can something be async when it has to draw on the screen? So like when you hit a letter and it shows up on the screen, that has to be a UI threaded thing, right? That the UI changes. So how can you make the editor async? How does that work?
So we try and balance. You have to choose the optimal balance between perf concerns, I think, and the need to, or the desire to make things asynchronous and make things non-blocking. And so the majority of completion actually is asynchronous, but typing is still a synchronous action. So if I'm a user and I'm typing hello world, HELLO, you should see those characters appear almost immediately. Completion gets scheduled on a background thread though, and it starts computing that set of items that will apply to whatever location the completion window ends up popping up at.
Yeah, right. So okay, so the typing itself is not async, because that would then delay what I see on the screen potentially.
Correct. Yeah.
But there are other things that we can then move off of the UI thread to the background, and then schedule once it's done with its initial computation. Like in IntelliSense, for instance, once it's figured out what the full list of items for the list should be, it bubbles it up to the UI thread, and when the UI thread has a available moment, it shows it. Is that how to think of it?
Yeah, that's basically correct. And then we try and limit any synchronous actions associated with completion to like very, very narrow windows to minimize the chance that they'll cause any sort of impact on your UI responsiveness.
So have we made everything async that we should so far, or do we have some places we can optimize?
So I think there are a number of efforts kind of happening in parallel to make that happen. So completion, quick info are both asynchronous. If you haven't switched to those APIs and you're on the call today, highly recommend switching to them. As a bonus, I'm not sure what the state of extensibility is for VS Mac, but we actually share a lot of code with that product today. And so fundamentally, those two APIs are basically identical, as opposed to the older generations, which are Windows only.
Right. So, and I think suggestions so that's actually a question I have for you. Light bulbs. I think most people know them as light bulbs, but internally we call them suggestions or actions. What do we call them?
Yeah. So the API name, I believe, is
suggested actions.
Action source, something like that.
Yeah. Okay.
But yeah, we still call them light bulbs internally.
Okay. All right. I wasn't sure. It came up like a couple of weeks ago for the for another show. So okay, thank you for clearing that up. So someone here, Donnie, is asking, is there any NoSQL database where is all the completion data saved?
So really, that depends on the particular language service. So we provide most of the editor integrations as an API, and then it's up to the individual language service to decide how they want to implement that. I can tell you, for example, my understanding is that C++ does maintain some sort of database for their completions. But Roslyn, for example, I believe is actually computing all that information on the fly.
Yeah, I think if we just talk about those two things, and I'm not an expert in any of them, but I know a few things about them. I know that the nature of C++ has it such that IntelliSense has to be indexed. There's like an index that is created, and then then they just have to update the delta every time you make modifications to your code files. Whereas Roslyn loads what's called the Roslyn workspace all into memory, and so it knows all the source code sort of in memory, and you query that object model directly when you're writing C# or Visual Basic or F#, I guess. Is that fair to say?
Yeah, I think that's fairly correct. I believe the difference in implementation here really comes down to optimizing for one thing or the other. My understanding is that compilation time is faster in .NET from a loading the workspace perspective. So my understanding is that's the reason why they made that particular choice.
Right. Okay. Yeah. Thanks for that question. And then, but there's other languages such as TypeScript, JavaScript, and so on. And some of them are, and I don't know if that's true for JavaScript, but it might be. They're not using the editor APIs at all, are they?
Yeah,
that's a newer thing.
Yeah. So TypeScript and JavaScript are actually a very, very interesting example. So for anyone who isn't familiar with the composition of that particular language service, TypeScript compiler is actually written in TypeScript, meaning that it's running in an out-of-proc Node.js instance, from what I recall. And so the way that it's interacting with Visual Studio actually is through something akin to the LanguageServer Protocol. So it's actually a separate project.
Yeah, can you just explain what is the LanguageServer Protocol? Where did they come from, and why that and not the APIs that we've been talking about so far?
Yeah, so I think fundamentally it just comes down to a difference in architecture. So because the TypeScript compiler is written in TypeScript and it's designed to be self-hosting like a lot of mature programming languages are, we had to sort of make a decision. Do we want to integrate this process directly into your dev end process and bring all of that memory usage into your main IDE? If it encounters any bugs or glitches, do we want it to take down and crash the main IDE? But more importantly, too, I think there are perf considerations. Anything that's running in a separate process can have only minimal impact on the user's quality of life. And so by running all of this in a separate process, we're actually able to insulate the main UI process and what the user sees and interacts with from any of the compromises that were made by the Node.js post process, for example.
Right. So that's actually a good point, right? Because any language service, like let's say C# or C++, or even a third-party extension that provides a language service, if an unhandled exception occurs in their code, they can take down whole of Visual Studio. They can crash Visual Studio. But if it's running in a different process, and you just have some sort of communication between a thin layer in Visual Studio that knows how to talk to that process, then it doesn't matter if that process crashes. That thin layer can just start it back up. The user might not even know that there was a crash.
Yeah, that's correct. And that's definitely the general idea. I think a big part of it, too, I think, is the complexity of interop. I think anyone who's worked in the VS ecosystem long enough, you have benefited from a lot of investments in the debugger. The C++ and C and C# and Visual Basic interop is all fairly seamless. But if you're trying to make a language service for Go, for example, you don't necessarily have as robust of a set of tools to lean on for interacting between Go and C or Go and C#, etc. And so having a protocol, a stable protocol that you can use to communicate between Visual Studio and your browser allows you to more easily spin up language services for languages that Microsoft might not even have first-party support for yet.
Right. So for instance, the TypeScript language server, which is written in TypeScript, that's the same executable running in Node.js or whatever that is used in VS Code, that is used in full Visual Studio,
Right.
maybe VS for Mac, and maybe even other IDEs as well, and editors out there. So that does that mean then that any language server that's written for VS Code, an extender could, like if it's open source under like an MIT license or something, could take that language server for the language called Go, for instance, that you were mentioning, take that, and then just implement that thin thing in Visual Studio that just knows how to talk to that, and voila, we have Go support in Visual Studio. Is that what it is?
Yeah, that's correct. Exactly. So I think there's kind of an important distinction to be made. The language server protocol is designed to handle a lot of the more complex interactions between editor and some language service. So there's still some things that you may have to implement around project templates or item templates, or adding menus or some margins and stuff like that. But it attempts to provide the bulk of the value that you would get as an extender. And in fact, many of our first-party language services are actually looking at adopting this.
Oh, so it goes beyond just TypeScript and JavaScript. We're looking at other things. I know we have a few language servers, or at least one more coming. That's a brand new language to Visual Studio, and I won't say anything else. But I was very happy to see that the team, it's the web team, were able to implement a brand new language in a matter of like a few weeks, because they used an existing language server out there, and by them using the language server protocol, they can just talk from VS straight into that, and we have a full language with IntelliSense, with light bulbs, with all sorts of things out of the box, and it's a fantastic experience. And it benefits everybody because now we get to have more languages. But as an extender, I really like this whole idea because it means that even the languages that Microsoft doesn't invest in at the moment, let's say, or doesn't invest in for Visual Studio, because they invest in Visual Studio Code for that particular language, let's say. The ecosystem, third-party extenders, could just implement that and make that available to all Visual Studio users, right? And in an easier way than writing everything from scratch. That's phenomenal. That's almost like a democratization of language implementations, really.
Absolutely.
So where does that put the existing WPF, text view, text buffer APIs? Is that going away? What's going on?
No, I don't believe that's going away in the near future. I think the existing in-proc APIs provide an additional layer of control over what you get from LSP. So LSP, in a lot of ways, is, as Matt said, it's a democratization of the API. But any fine-tuning you may want to do, or if you want to extend user interface, or if you want to provide additional dialogues or windows, or if you want to provide adornments in the editor, for example, those today are still done via in-proc extensibility.
Yeah. So so is it fair to say that the language server protocol is a subset of the capabilities that the full editor APIs got? There's just things that is not yet in the language server protocol, and language server protocol is almost like a standard. You kind of add to it over time. It evolves over time. More and more features will be added, but that's true for the Visual Studio APIs as well. So it stays ahead. You can do more.
And so, I would like to say that we are actively investing in LSP protocol and making it as rich as possible right now, so that it can adapt to a broader and broader set of scenarios.
Okay, so that might even be evolving faster than the traditional editor APIs.
I'd say we're actually working on them in conjunction. So right now, for a little bit of background, I am on the editor team, but we have assumed ownership of parts of the LSP protocol client, and we're actively working to make those scenarios seamless, whether you choose in-proc or out-of-proc extensibility.
All right. Okay. So we have Jonas here. He's like, he really hopes that Rust is going to make it in, and apparently that I'm going to make a Rust extension. You know what, Jonas? Look no further. It's already out there. It's been out there for a few years, actually. So the team that did the language server protocol originally, which happened to be the extensibility team originally, they actually put out their sort of a proof of concept for interacting through the language server protocol from Visual Studio to an existing language server. I think it was written for VS Code originally. And so it's out there. It's on the marketplace, marketplace.visualstudio.com. So that already exists. So that's a bit of good news. We have another here that I kind of like. At the risk of sounding like a broken record, can we expect to see a WebView 2 based on Edge, not the WPF web browser support in Visual Studio?
So that unfortunately falls outside of ownership of my team. So I don't know what the plans are there.
I think we can talk a little bit to it, right? Because so today, if you want to use a web view, you have to basically host a WPF web browser control, or even a Windows Forms web browser control, or I think it's just called browser control actually. But nonetheless, you have to host it yourself inside let's say a tool window or a margin control, anywhere you can host WPF, basically.
Mm-hmm.
It could even be a tooltip, right? It could be anywhere where you can host WPF. But didn't we recently do something to get the newer version of Edge, the Edge Chromium version, into, is it the terminal that has the new terminal that we shipped in Visual Studio 2019? Is that the one? Or I'm confused. I think there's some effort somewhere to bring it in, but I don't think we have any plans for like a release date or something like that. Do you know anything there?
You
look at all the PRs going into Visual Studio. You might have seen something.
I don't know much more than investigations, but I can only speculate as to what will come out of that.
Okay. Yeah. So I guess it's too early to say, but it's definitely something that people have been requesting for a long time. So good question. Okay. So LanguageServer Protocol seems to be a technology that's really interesting if you want to target many different IDEs like VS Code, VS for Mac. Does VS for Mac support LanguageServer Protocol?
So my understanding is that is in the pipeline. Again, this kind of falls under the same category as the WebView 2 thing. We don't know when, but I believe that is something that we want to support at some point.
Yeah. Okay. So, but it's kind of future-proof, because let's say at some point it does support it. Well, then all of a sudden you have a very easy way to have support for your language in yet another IDE out there, right? And so this is not just Microsoft IDEs. I believe that even the competitors, editors and IDEs support LSP, LanguageServer Protocol. So that might be a nice way if you have a language and you want to have great support for it in a bunch of different IDEs. The flip side is you cannot make it as rich as you otherwise would have if you used the traditional APIs. Or can you mix and match? Can you say, I'm going to use my language server to provide IntelliSense, tooltips, quick info, light bulbs, all this sort of stuff. And then I'm going to use native implementations in Visual Studio to add the last pieces of the puzzle, like adornments, code lens, all these things. Is that possible?
Yeah, you can absolutely mix and match. I want to give a particular example here. Returning to that example of TypeScript, I believe that at one point in time, TypeScript was actually receiving colorization through TextMate, which is another technology that the Visual Studio editor owns. It allows you to do declarative colorization or classification of your document. And they were using LanguageServer Protocol to light up most of their features. Eventually, they realized they wanted to have support for semantic colorization. So they actually provided an in-proc extension using that tagger API I was talking about before to provide classification tags, it's a form of information that the editor can use to map from a span of text to a color. And so we use that to superimpose an additional layer of colorization on top of what was provided by their out-of-proc and TextMate extensibility.
Right. That makes sense. And then you mentioned also something like item template. So let's say it's TypeScript. You want the users to be to be able to say, I want to add a new TypeScript file, and that's called an item template.
Yeah.
But of course, they're not part of the LanguageServer Protocol, because each editor or each IDE have their own way of dealing with templates. And I'm sure there's other concepts as well. Snippets might be another one that's individual for each. I don't know. But so in that case, you implement basically the basic LanguageServer Protocol that talks to your language server that runs out of proc. And you then sprinkle in those things. And so minimal amount of work for each editor, and you have a full-fledged.
Yeah, I think a useful way A useful way to think of this might be your language server can be like the engine that drives a lot of your experiences. And even if we don't have something in the protocol today, you can theoretically still communicate with that engine from an in-proc extension and provide that additional layer of extensibility on top that you need.
So I know that there's another related technology called the debug adapter protocol, which is basically how do you debug a language or debug a program running. And I think Visual Studio Code uses it. I think Visual Studio and Visual Studio for Mac might actually also support it, so that you can now debug anything you want. Like you just install an adapter for a specific language or runtime or something like that, and now you can like step debug and set breakpoints and all this sort of niceties that we're used to. So and I think they came out sort of at the same time or similar time. But are you aware of any other things that are like of this nature? It seems like a really great way of building editors, very extendable.
Yeah, so I think there's a whole series of protocol possibilities for things that can be moved out of proc. And I know that this is a general thing that we're interested in doing just because of the resiliency benefits that we can bring to our customers by moving things into separate processes. I'm failing to find any particular examples off the top of my head, but I know that there are others that we were interested in looking at.
Yeah, and so the idea is that from us, from the Visual Studio team, and from you as you own the underlying API, you don't actually own any language implementation like C#. You just own the APIs at the bottom. So you can, your API can be more stable and resilient if you start moving things out of proc. So something like colorization, let's say, like syntax highlighting, it's also called, is no longer able to crash Visual Studio if you have a bad extension that does something that shouldn't have done.
Yeah, I'm glad you mentioned that, actually. So something that we have done for 16.8 preview, and it should be in the previews with the right set of preview features enabled, is actually... So
that's the latest preview of Visual Studio 2019, right?
Correct, yeah. There is actually syntax highlighting from an out-of-proc language server that shows up in certain niche scenarios, such as live share. And so it's...
Oh, yeah, that's an interesting point, right? Because when we're dealing with live share, now you have... So just... if people are not aware of what live share is, it's a way that you can share your instance of Visual Studio across the internet to one or more people that has Visual Studio or Visual Studio Code. They can connect into your session and they can see the same thing you can, the same project, the same file, open them, edit them, but they see it from their editor or ID and not from yours. So Visual Studio Code can connect to Visual Studio, but they will see it in Visual Studio Code, and all their extensions and all that sort of stuff works. But now we're introducing basically two cursors, right, or more, into the same document. You can have the same document open, and let's say Christian and I was sharing my session, then I could type in the document at the same time that you could type in it. And now we're dealing with like the complexity just exploded, right? Because how do you reason about that? And also, how do you transfer stuff like IntelliSense from my machine to yours without something like an LSP that is the underlying connection, right?
Yeah. So the majority of those experiences today, I believe, do actually go through LSP, but we do have a number of different protocols today which implement a lot of that functionality. We try and isolate or insulate the extenders from having to worry about that knowledge. So for the most part, it should behave the exact same as if you just have one local user. Yeah.
You know, I was always wondering when you do live share and you have multiple cursors, how do you handle undo? Like if I undo on my side, am I undoing my actions or yours or both? Or how do you reconcile that?
So I have to answer this question with the caveat that I'm not the expert on live share. I believe what happens is each person gets their own copy of the edit. So I want to say that you can undo anyone's change, but I'm not entirely sure.
So normally when we're talking about undoing in the editor, we have this concept of an undo buffer, right? So every action you take adds sort of an entry to an undo buffer, and then you can then roll back when you undo, or roll forward again if you redo. And with live share, that might then be completely different.
Yeah.
Or separate somehow.
And one notable difference I'd have to say between LiveShare and what we have in just the local scenario today is the existence of global undo. So if, for example, you do an inline rename and you change symbol name across a whole bunch of files, we have to have the ability to undo that. So I don't know what the scenario looks like in LiveShare today, but I know there are ongoing efforts to make those as robust as they are in the local scenario, and just generally overall bring like a much more seamless experience.
Yeah. And so when we're talking about undoing, we're talking about the editor specifically, right? Because if you take, let's say you add a file to a folder in your solution, in your project, and you hit undo, that doesn't remove that file from existing. So the undo stack or the undo buffer or whatever it's called is unique to the editor, or do each different feature have their own way of undoing? How does all that work?
That's a good question. So I'm not as familiar with how it works in LiveShare specifically. My understanding is in the local scenario, I think each file has its own undo buffer. But then I want to say there's also a certain point at which it merges with the global undo. And so if you undo far enough, you can actually undo global actions. And generally, you'll get a warning dialog which will say, this is going to undo a global action. You usually can't redo this. Something akin to that.
Right. I've seen that before. Okay, I've seen that dialog. Okay. Yeah, it always took me by surprise how hard I thought something as simple of a concept as undoing is. So I think that the APIs that you have built, with the way you can in an extension, if you want to extend the editor, implement your own language in your text buffer, when you want to manipulate the text, you kind of do it in a using statement, and then you apply at the end. And so you can have multiple different things that you change in the text buffer, and then you just at the very end you just apply it, and that's when it becomes visible. And then when you undo that entire chain of things that you just introduced. And I thought, oh, I never thought of it as being transactional and like all these different things about undo, but it is one of the more complex things.
I'm glad you mentioned the transactional nature of the editor. So for anyone who hasn't delved too deep into the text buffer APIs, the way everything is generated, all edits are transactional. Like you construct a series of individual edits which go together in a single transaction, get applied together as a single series of text changes and sort of like one atomic change. But more importantly, the text buffer at a particular point in time is tracked by a text snapshot. So this is a moment in time image that's immutable that you can use to analyze the text, to do any work that you need to do in the background. And then you can later translate to the new text changes if the user continues making edits in the meantime. Right.
So I noticed, so there is, and in the API, and by the way, I will say it's a pleasure to work with the API. It's kind of modern, it's new, it's all sort of .NET, and it feels very .NET-y. The events are regular .NET events, and on the text buffer, there is literally an event called changed.
Yeah.
Like you can subscribe to an event that happens when the text buffer changed. So that means someone pasted something in or typed something or deleted something, for instance. But what I've noticed is that event, and I think maybe all those type of events, they're all happening on the UI thread.
Mm-hmm.
And so if you want to subscribe to something that happens every time the text buffer change, that's going to get fired all the time on the UI thread. And so so it's easy, and I've been guilty of that, I do too much work on the UI thread. I'm not realizing that I'm slowing down the performance of typing because I'm subscribing to this event and doing some work, probably analyzing the whole document to see if there's something I should be aware of or whatever. And what I should have done is probably taken that async and come up with a pattern or whatever. But the point is, you can, even with a great design that the API has, you can still kind of shoot yourself in the foot. You can still make it a worse experience for the user out there. How do you ensure, or how do you help from that to happen, both internally when we have like language services that ship in Visual Studio, but also third parties? Or is there anything they can do to figure this out on their own?
Sure. Yeah, I think the simplest and most straightforward way of doing this actually is just using LSP protocol. And that may sound like too heavy-handed of an approach, but the advantage there is you don't have to actually worry about impacting the UI thread. That falls that responsibility falls squarely on the LSP client, its implementation, and any trade-offs it makes. If that's not acceptable, though, the next best thing that you can do is using the newest version of any in-proc API. So newest version of most in-proc APIs are asynchronous, meaning that if you have to do disk IO or if you have to make a network call, you're not going to block the UI thread during that time. And better yet, if you need to switch to another thread, such as a background thread, you can await the results of whatever your computation was, and then dispatch the update back to the UI thread again fairly seamlessly. The third best thing, if you don't have access to either of those two for your particular scenario, and I think text buffer changed might have an asynchronous event handler that you can subscribe to, but if it doesn't, what you can do is you can queue asynchronous background work. So a task.run and join that work later when it's completed, or have it post back to the UI thread. And we use a combination of all of these different strategies in a lot of the work that we do.
Okay, so is it possible? Do you monitor if let's say someone has a bad implementation that slows down typing? Are you alerted of that somehow through telemetry or something, and can reach out and say, "Hey, you need to optimize your thing"? And is that a thing that happens?
Yeah, this absolutely happens. So we have a couple of scenarios that we know that customers are particularly concerned about. Typing performance is one of them, solution load, Visual Studio startup. And most frequently, I think this will manifest as some sort of user notification saying that this particular extension is using a deprecated API and may be impacting your responsiveness. We try and avoid that as much as possible, but it is one particular mitigation that we can offer to the customer.
Right.
But the best thing that we can do ultimately is, avoiding any deprecated APIs, using async things whenever possible. And we've managed to avoid that with a lot of scenarios.
So internally, whenever there's a new API from the editor, we see those different language teams like C#, let's say, converting to the new API to have even better performance characteristics or just get newer features. And I also take it like not all teams does it at the same time, right? That priorities and whatnot.
It's very much an incremental and ongoing bit of work. I think this particular issue really highlights the need to be data driven. And so one of the things that we do is we track the incidence of UI delays and what the root cause is in each of these important scenarios, so that we can triage them, route them appropriately, and make sure that they get handled in a timely fashion.
It's kind of interesting. It's pretty telling about just the size and the scope of Visual Studio that the team that owns the editor doesn't own the implementation of the languages, right? They're completely different teams. Back when we actually were working in the offices, they might even be in different, or probably they were in different buildings even, and you might never have seen the people that implemented those things. And so trying to get everyone on board to the new APIs, and I take it like even some languages are, more or less actively being developed, and so it can be hard even to prioritize some languages that are like maybe very infrequently used to use the new APIs, and that must be an ongoing challenge for your team.
Yeah, absolutely. And just to give a good indication of like the size and the scope of the problem, I think when I joined this team 4 years ago, I saw the name editor team and I was thinking this is going to be just UI, it's going to be just WPF. But the majority of what we own is actually a set of libraries, which are fundamental components, not just of the editor and the IDE, but of LiveShare and of the language services themselves. If you look at some of those language servers that I was talking about that implement this LSP protocol, a lot of them actually have core bits of the editor data structures that they build upon. And so really our role extends beyond just UI and more into what can we do to set up our partner teams for success.
Right. So there is a third option, and you talked about just a very little bit today, but we mentioned we have the big APIs of Visual Studio that can do everything and anything. And then we have the LanguageServer Protocol, which can do a lot of things, but not everything. And we have a larger extent of reuse doing that. But then we have one thing that is even simpler, but it has very limited features. It can do syntax highlighting or colorization. It can do code folding or outlining. And it will do that automatically. You don't have to think about that. It just happens. And it can do snippets to some extent. Not fully, but to some extent can do snippets as well. And it will do auto-completion. Not full IntelliSense, but give you basically completion of whatever symbols they can find in the same document. And that's TextMate. And there's probably hundreds, if not thousands, of languages in the world written in TextMate, what's called a TextMate grammar or TextMate bundle. And you can just take those, right? Maybe not any single one of them, but a large percentage of them will just work inside Visual Studio.
Yeah, that's correct. So for a little bit of background on TextMate, this is an open standard that's kind of sprung out. I think it was originally invented by the TextMate editor on Mac. And over time, it's gained popularity across a number of different editors. So Visual Studio supports it, VS Code. I want to say that Sublime Text might also as well. But it's become sort of an informal standard for specifying your language hierarchy or your language structure, your grammar. So TextMate in Visual Studio can be used to provide code colorization. That's probably the most compelling case there. But then we also can use it to infer hints from indentation about how we should implement code folding for your language. As Mads was saying, we provide word completion. It's not really IntelliSense as much as that we go through and we tokenize the document, we find every unique word and we put them in the completion list so that you can auto-complete things that you typed previously in that same document. So in a lot of ways, it's a grab bag of language service components that you can put together that are designed to sort of implement that baseline level of functionality that you get in VS Code with no extensions, for example.
Yeah. And one thing that I really like about them is that they have a feature that none of the other ways of extending the editor, or in general, like I think only templates has this same feature, like whether it's item templates or project templates. And that is that you can just put them in a special folder on disk and they will work. You don't have to write an extension to ship them. Just put them in a folder. And I actually just wrote this on. You tell me, Christian, on the screen here, if this is the right folder name.
Yeah, that's the correct folder name, yeah.
So this folder name, it's under your user profile. The .vs folder does not exist. And if it does, the /extensions folder inside that does not exist unless you create it to put in TextMate. Is that right? It's only used for this.
Yeah, that's correct. One thing I do want to mention, I see a question here about the TextMate XML model. And I just want to acknowledge that I saw that comment. My recipe for success with TextMate grammars, I think, is to keep them as simple as possible. I have seen some that are 20,000 lines long and they have 150-line regexes with comments. I would put that in kind of the extreme where it gets difficult to manage. So, using it for things like highlighting keywords, et cetera, is kind of a good way of providing baseline level language smarts. But anything beyond that, I would recommend actually layering like a classifier or a series of editor language services on top of that.
Yeah, that's exactly my experience too. I've done a few TextMate things, and I've never been able to write them from scratch. I always take one that exists that works in Visual Studio, and then I kind of modify it to my particular language or whatever. And that seems to work okay. But I agree with the comment here. It's like they're hard to write. You can do them in XML, you can do them in JSON, and you can do them in YAML, and all three are supported by VS.
So YAML is a preprocessor format. My understanding is that there's some NPM library, I believe. I think it's called NPM.js or something that will actually convert from YAML to JSON or XML, if I remember correctly.
Oh, okay. So if you find a YAML file, you can just go online, convert it to JSON or XML, and then use that in your TextMate.
Yep, I believe so.
Source. And TextMate also has the concept of snippets. It has the concept of themes, and a few other concepts like I think commands and stuff. But what is it? What parts of TextMate is it that the editors support?
Yeah, so we do have some limited support for TextMate snippets. I would not recommend going that particular route if you wanted to ship a snippets experience, just because there's a couple of things that you need to make snippets a really compelling experience. One of them is smart indent and code formatting. So for example, if you paste in a snippet, we don't know how much to indent the code without a full language service behind there. So in that sense, you're probably better off just using regular Visual Studio snippets. The most compelling use case is probably colorization, structure guides, outlining, and maybe word completion. So we actually do have a number of first-party language services that do use the first three of those features. So JavaScript, TypeScript are both colorized at the base layer with TextMate. And I believe in the preview channel, the most recent 16.8 preview, there is actually a preview feature for using TextMate for ASP.NET Razor as well.
Yeah. Right. Okay. And so but not just that, Visual Studio ships with like 30 TextMate languages, right? Because we even have one for things that we don't normally use it for. So let me give you an example, like HTML. So we have a language server for a TextMate grammar file for HTML for the cases where you don't have installed the Visual Studio component that brings the HTML editor. You don't have the web tooling installed, what we call the web workload. And so if you open an HTML file, you would still expect to get sort of basic colorization and stuff. And so that's why we ship all these different TextMates. But we also ship other ones that are not something that we would otherwise have, right? So I don't know if we have Go or Rust or some of them, but we might have. I'm not sure.
I'm not sure about those two specific ones, but I would like to add a concrete example for where this scenario can be useful. So Visual Studio is a polyglot project. We have code in a bunch of different languages that all kind of interops together in various processes. And one of the things that we have to do quite frequently is crash dump analysis. We want to keep the experience to be high quality for all of our customers. And sometimes what will happen is I work in a primarily C# area, so I've only installed the C# workload to minimize my install size, keep it nice and light at update time. But then I open this crash dump and I'm seeing C++ code and I'm analyzing this crash and C++ line, I'll still get code colorization even without the full language service because we have TextMate installed.
I have this on Fridays. I do this live Visual Studio extension code writing on YouTube and Twitch. I should do one where I write some TextMate just because I think people are going to be surprised at how simple it is. Usually when I say write a TextMate, I basically mean go Google for it and use it in your own extensions because it's sometimes that simple, if the license allows for it, of course. So that's a great way of adding additional languages, super easy. So, okay, so there's three levels of languages, language services, right? And you think the order is correct? Like at the bottom, we have the TextMate. You can't do that much. LanguageServer Protocol, huge step up. And then a little bit over that, we have the built-in, the native Visual Studio APIs.
Correct. Yeah, that's correct. And I would definitely recommend, I think, if you're building a new language service or if you're looking for a direction to migrate, I think at this point in time, that's the order in which I would recommend adopting things just because of, from a future-facing perspective, that flexibility that you get being able to communicate through a protocol may be useful in the near future.
Yeah. Okay. Well, thank you so much, Christian. This was awesome. And our time, unfortunately, is up. I want to be respectful to your time and everyone watching's time. So thanks for coming on.
Yeah, thank you for having me.
And if you have any other questions, feel free to tweet us both. And whether they're about the editor specifically or Visual Studio in general, it's all good. So until next time, see you then.